Hey guys, it's Landon with Taught by a Surveyor, and this is a video, another video we're doing on geometry, kind of basic 2D geometry. Today we're going to talk about circles and circular arcs. In this video, I'm going to tell you why we care about circles. I'm going to define a circle, define an arc, talk a little bit about the properties of a circle and the properties of an arc. We'll go over some bits and pieces of this little beautiful diagram I have over here on the other whiteboard. So if you remember your junior high geometry class, elementary geometry class, a lot of this will be a review, but it's okay if you need to review. So why do we care about circles? Why are we talking about circles? Well, circles are actually really important. They're really important. They're an important part of geometry, and they're important to land surveyors. So they're important. A couple of the reasons they're especially important to land surveyors is we use circles in what we call COGO, or coordinate geometry, especially for intersection calculations, which I'm not going to get into in this video. But circles are a tool. They're a tool that land surveyors can use to solve problems, geometry problems. We call those intersection calculations. Circles are also important because engineers like to join the straight segments of roads with circular arcs. So we help engineers build stuff, and engineers like circles. Architects like circles too. We help architects build stuff. So we got to know a little bit about circles because that. And they're an important part of math and an important part of geometry. So it's kind of cool. We'll talk a little bit about pi. Pi is a really cool number. It's an irrational number that is a really important part of circles. But pi also creeps up in other parts of geometry and other parts of mathematics that have nothing to do with circles, which is really, it's kind of a cool pattern in math. It's one of the beautiful patterns in math. Pi is a beautiful number. There's been whole books written about it. It almost makes you think, like there was somebody with a sense of humor designing all this mathematics, right? So, pi comes from circles. So it's a really important contribution that circles make to geometry and mathematics. Okay, so what is a circle? I got to come up with a definition of that. I'm not going to give you some dry, hard to understand textbook definition because those aren't very helpful. So the way I would define a circle is as a ring on a 2D plane where every point on the ring is the same distance from the center of the ring. Okay, and that rule that each point on the ring has to be the same distance from the ring, that's a really important rule. That's what makes a circle a circle. So for example, you could have a ring that looks like this. That is not a circle. That's what we call an oval or an ellipse. And you can see that this point is farther from the center point than this point up here. So point A on the ellipse is farther than point B on the ellipse from the center point. And ellipses are another cool shape. We'll have to do some videos on ellipses too. But a circle has that special constraint or restriction. Every point on the ring is the same distance from the center point, what we call the radius point. That's what surveyors call the radius point of the circle. Okay, so that's how I define a circle. What is an arc? An arc is just a piece of the ring of the circle. So it's not the whole ring, it's just a piece. So you can see I've got the arc there in pink. So it's a portion of the ring that makes up the circle. So what are some properties of a circle? So some properties of a circle, I actually wrote these down because I didn't want to forget. So you have the diameter of the circle. That's how wide the circle is. Okay, so any line you draw through the center point that touches the two circles is going to be the same length, and we call that length the diameter. Okay, half of the diameter is what we call that the radius. Okay, so diameter, radius. Okay, and then this distance all the way around the ring, if you were to measure that, we call that distance or length the circumference. In other words, how far around the circle is it? Circumference. Okay, now one of the cool things about geometry is we can never know the exact circumference of a circle. We can only guess, we can only approximate it. And that has to do with the fact that pi is an irrational number. I won't get too in the weeds on that in this video, but we can only guess at the true circumference of a circle, okay? But that's another property of the circle. So we've got diameter, radius, circumference. Let me make sure I'm not forgetting anything. Now, surveyors typically, we don't just care about the shape of a circle and the size of it. We also care about where it's at in space. And to do that, we normally assign a coordinate, an x and a y, or a y and an x, a northing and an easting, to the radius point. That's how we locate a circle in space. Okay. Now let's talk about the properties of an arc. So an arc has an arc length instead of a circumference. So that's how far it is along the arc. So it has an arc length. Okay, and then we also surveyors seem to do this more than anyone else, but we also talk about this arc extends an angle. Okay, we call this the central angle of the arc, or sometimes you'll hear it called delta, the Greek letter delta. Okay, but I like to call it central angle because we don't speak Greek anymore. Okay, so that's the arc. So it has a length and a central angle, and there's a relationship between the length of the arc, the central angle, and the radius. I won't talk about that in this video. We'll do some other videos where we solve some arc problems, and we'll look at that relationship a little more. Okay, and then an arc has a start point and an end point, and if you're a surveyor, you know, we like to know where that is. So we like to have a coordinate value. We like to have a coordinate value or a northing easting on the start points and end points of our arcs, because we like to know where things are in space. Okay, so start point, end point. Sometimes you'll hear surveyors call that begin curve, end curve. Okay, start point, end point of an arc. The last thing I wanted to show you guys in this video is the relationship. So we talked a little bit about that special number pi, and that's the symbol you use for pi. Okay, it's spelled P-I, pi. Pi. It's one of the shortest words in mathematics. All right, so pi is just the relationship between the diameter of a circle and the circumference. Okay, so the circumference of a circle is about 3.14 times the diameter. So the circumference is 3.14 times the diameter. So another way to write that, if we wrote it as like an algebra formula, circumference equals the diameter times 3.14. Now, I say about because pi is an irrational number. If you want really accurate calculations, you got to carry pi out to, 9, 10, 12 decimal places. We'll look at that. We'll look at that when we do when we solve some problems related to circles and arcs. Do that in a different video. But if you watch one of my other videos, you remember math is not always exact like people think, right? Math can be fuzzy. And one of the reasons geometry is fuzzy is because pi is an irrational number. I've got a video where I talk a little bit about irrational numbers too. Check that out. All right, so those are the basics. Those are the basics of circles and circular arcs. I call them circular arcs because in geometry, especially in graphic design, there are other kinds of arcs like Bezier curves, different elliptical curves. So a circular arc is a special type of curve. It is a curve. It's a special type of curve that falls on a circle. That's why I call it circular arc and not just arc. So just remember there's other kinds of curves besides circular arcs. I think that's all I wanted to cover in this video. We will do some more on circles and arcs and other kinds of curves and ellipses, all kinds of really interesting stuff to talk about. If I remember, I will try and find a cool video on YouTube about pi and how pi gets calculated, and I'll try and link to that in the comments on YouTube. So thanks for watching.